Hello students, welcome to underground metalliferrous mining classes. Today we are going to learn about what are the plain detonators and delay detonators. In the previous class we have completed what is the definition of an explosive, classification of an explosives, properties of explosives, permitted and non-permitted explosives. Today we'll cover the detonators or instantaneous detonators and delay detonators. Now, in general, the explosive initiating devices will be divided into detonating system and fuse system. In case of detonator system, we have instantaneous detonators, delay detonators, special type detonators. The plain instantaneous detonators or electric instantaneous detonators, and in case of delay detonators are subdivided into electric delay detonators, non-electric delay detonators and electronic delay detonators. In case of electric detonator, further subdivided into long delay and short delay. The long delays are half-second delays and short delays are millisecond delays. In case of short delay detonators, the non-incentive types are used in the coal mines. The special type detonators, here it is used in the special occasions and in the mines. We are much familiar with nonal systems, whereas other we are not familiar because it is used primarily in the special cases. And the fuse system are of two types. The first is fuse, safety fuse and detonating core. Now we'll enter into detonators. The plain detonators, these are fired by a safety fuse. The spark or the spit from the fuse causing the detonators to explode. These are sometimes called ordinary detonators. Now, detonators, see, we could see an aluminium tube filled with a base charge and a priming charge. The base charge is PETN, pentaerythritol tetranitrate, and a priming charge of ASA, which is lead acid, lead stephnite and aluminium powder, that we called as flaked aluminium. Now, detonators primarily of two types, number 6 and number 8. Whereas number 6 detonator, which has 60 centigrams of charge and 35 centigrams of primary charge and 25 centigrams of base charge. The primary here, this number 6 detonators will have the less explosive materials in it, where compared to the number 8 detonators. These are used primarily based on the requirement of detonating energy required for a particular explosives where we are using it. Now, in case of number 8 detonators, the 80 centigrams of charge. 80 centigrams of charge consists of 30 centigrams of primary charge ASA and 50 centigrams of base charge. The example is pentaerythritol tetranitrate, that is PETN. Now, this is your PETN in the powder form. Ordinary electric detonator. In ordinary electric detonators, which is a non-delay type or instantaneous type, the priming charge and the base charge are the same as of the plain detonator, but they are fired not by ignitions of safety fuse but by passing an electric current through a fuse head. The current ignites a flashing composition in the fuse head, which in turn initiates the priming charge. Now we could see this is an aluminium tube or a copper tube. Inside this there is a base charge and a prime charge, as we have seen in an ordinary detonator. What is different here is your fuse head. The fuse head with the leading wires. This remains different compared to your ordinary detonator, which is connected with your safety fuse. Here in this fuse head are of two types. One is low tension fuse head and high tension fuse head. The low tension fuse head, which has the low tension fuse head usually we use in our mines. Okay, first, before knowing the fuse head, we have to know one small knowledge about the fuse head. You have seen your regular bulbs. The bulb consists of tungsten, that means your tungsten bulb. As the current passes through your tungsten bulb, the light glows inside the tungsten bulb. Similar things happen in your low tension and high tension, whereas the tungsten carbide, it happens only in the low tension, not in high tension. In case of low tension fuse head, the tungsten carbide is being placed as similar to your tungsten carbide. When the current passes with these two leading wires, this tungsten carbide starts glowing, and which creates a spark here. This spark is enough for initiating this prime charge. As the prime charge initiates, again it explodes the base charge. In this way, the initiation takes place in case of an electric detonator. Now, if you have seen here, this your ordinary detonator along with your safety fuse inserted here. We'll go for next slide. This is your electronic delay detonators. An ordinary delay detonator will have your base charge, prime charge, and connected to your safety fuse. In case of your electric detonators, will have one more called fuse head to be inserted in it and leading wires. That will become your electric detonators. In case of electronic detonators, it will further has one more installation in it, which is called capacitor and delay modules. The capacitor here works as a storage of the energy here. As the power passes through this detonator, it stores in the capacitor. This is your chip. This chip primarily will be inserted in your system or connected to your system on the surface, and we set the time. At particular time, this has to get exploded. We set the time and then insert this electronic detonator in the primer or booster, usually in the primer, and then insert in the blast hole. Now, once the current passes through this detonator, this current passes through the delay module and then to the capacitor. In capacitor, this current starts storing. During this particular time, as you have set in the surface, in that particular time, this energy is released. As the energy releases, this fuse head starts giving the spark. As the spark is initiated, this detonator is detonated. Now, before this, we have to see. Okay. Here, this is your ordinary detonators, which is of copper or aluminium type. There is no any much difference here. See here, in case of ordinary detonators, you would have seen the base charge and the prime charge is here. The white which you could see is a PET and pentaerythral tetranitrate, and the above charge is your ACl, lead acid, lead stephnite, and aluminium powder. Next we come with electric detonators. We have here there are two types. One is the copper instantaneous electric detonator or aluminium instantaneous electric detonator. In case of copper instantaneous electric detonator, you would have seen here there is a fuse head, the leading wires coming out, both the cases, prime charge and base charge. There is a difference. And next we come up with the half-second delay detonator and millisecond delay detonator. Both are of varying sizes that starts with your 32 mm to 52 mm, which is of various sizes. There is a delay element here, which you could see here, the base charge, prime charge, and a delay element to be placed here. And case of millisecond, it is of delay element to be placed here. Now you could know what is safety fuse and detonating cord. These are safety fuse and detonating cord. Now, in case of electronic detonators and normal delay detonators, you could see here there are shock tubes and electric detonators. Shock tubes, same electric, which consists of a capacitor in the electronic mode. Now you could see a shock tube is nothing but a nonal, which we could learn in our future classes. The both has a pyrotechnic delay element to be placed here. The delay happens here using a pyrotechnic element, whereas in case of an electronic it happens through a capacitor to be placed. That's a difference. These are detonators. Now we'll see a video.
The first step of the process is to drill holes to place the explosives inside the rock we want to break. Inside each hole, a primer is used to initiate the explosives. Several types of explosive products can be used to charge the holes. Essentially, the holes are filled with either packaged or bulk explosives. Primers are made of packaged emulsions.
See, these are detonated, inserted inside the explosives, and this one booster.
The explosion exerts very high pressures way above the rock strength. This creates a zone of crushed rock immediately around the hole. The explosion also generates a shock wave which starts the cracking process. The explosive gases generated expand extremely quickly, forcing cracks apart, breaking the rock and pushing it into the nearest void. Long holes may use multiple primers. They are typically placed at the toe of the blast hole and then at predefined intervals as determined by the drill and blast engineer.
So booster is being inserted along with the detonator.
Enough primers are used to ensure that the long explosive column is initiated. Even though
Now we'll go with the MCQs for the day. Which explosive is blasted by a safety fuse? This gunpowder. The velocity of detonations of OCG is 6000 meter per second. The elements in the delay element of a short delay detonators is red lead and silicon. In case of long delay, it is silicon and antimony. Sorry, it is antimony and potassium permanganate. See here. The elements in delay element of a short delay detonator is red lead and silicon. In case of long delay detonator is antimony and potassium permanganate. The main element in the fuse head of a detonator is lead mononitroresorcinol. The current required for ignitions of the fuse head is 0.5 amps or 3 volts. Thank you.